Hello class. So today we're going to look at the atom. So if you remember last on Friday you looked at the history of the atom and where it came from and the scientists that kind of started figuring out the parts that make up the atom. So today we are going to look in depth at that. So again, when we look at the atom, it is the smallest particle of an element that has all the properties of that element. And so the two main components of that atom is going to be the nucleus and the orbits around it. So when we look at the diagram in the center here, okay, right in the center, that is going to be our nucleus, okay, and these orbits or circles around it are going to be, those are your orbits that carry the electrons. So atomic structure. So the nucleus is going to contain two types of subatomic particles, the proton and the neutron. The orbits around that nucleus contain only electrons, and the number of orbits around that nucleus will depend on how many electrons there are. Okay, and we will get to how we can look at that. Okay, so the atom. The atom is always neutral, meaning it does not have a charge. So we know that the number of positives, okay, in the nucleus is going to be the same or equal to the number of negatives that are around it, which means that the number of protons equals the number of electrons. So if we fill out the chart here about subatomic particles, so the first subatomic particle is the proton. Okay, it has a mass of 1 AMU. Okay, and remember 1 AMU is 1 atomic mass unit. It has a positive charge. We know that it's in the nucleus. And the symbol we use to represent protons is that P with the positive sign. The second subatomic particle is the neutron. Okay, it too has a mass of 1. It doesn't have a charge, so we do consider it neutral. Okay, it is with the proton, it's found in our nucleus. And we can represent that with an N and a little 0 because it doesn't have a charge. So the electron is the third type of subatomic particle. It does not have a mass, so we say 0 AMU. It is going to have a negative charge, and it is found in the orbits that are around that nucleus, and the symbol we use would be an E with that negative sign. Okay, so those are our subatomic particles, and then a little bit more with regards to its charges. So atomic number. Okay, it is unique for each element, okay, which means that every single element on the periodic table has its own atomic number. It's the number of protons and the number of electrons that an atom has. So when we need to figure out how many protons an element has or an atom has, the atomic number is what's going to tell us. Okay, so you have a periodic table reference sheet, and so when you look at that periodic table for each element, there's a little square on the periodic table that gives you information. Okay, so obviously you have the big symbol, you have the name that tells you the name of the elements, but then there's two numbers on that periodic table, and so the top one here, okay, that's telling you the atomic number. Okay, and the bottom number here is telling you the mass of of that element. Okay, so again, if you take a look at your periodic table, hopefully you can see the atomic number, you can see that mass number, because you will need to be able to reference those. So for our first example, here we go. Oxygen has an atomic number of, so when you look at your periodic table and you find O, okay, what number, okay, what's its atomic number? And hopefully you see the number 8. Okay, and that means, okay, so meaning a neutral oxygen atom is going to contain how many protons and how many electrons? Well, we know that the number of protons is determined by the atomic number, right, based on what was set up here. Okay, so we know that oxygen will have 8 protons and 8 electrons. So the atomic mass. Electrons have a mass of 0, so the nucleus makes up the mass of the atom, right? So we know that in the nucleus we have our protons and our neutrons, so that is where the mass of that atom is. Okay, so the sum of the protons, neutrons in the atom's nucleus will make up the mass, protons plus neutrons. So measure the atomic mass is measured in that AMU as well. Okay, so if we look at, again, oxygen, find that square on your periodic table for oxygen. Oxygen has a mass of, and I believe it says 16.0 is its mass. Okay, now most of the time we will be able to round that mass number to a whole number. Okay, how do we determine the number of neutrons? Since the mass of an atom is made up of neutrons and protons, whatever mass is not due to the protons, we can say that it's due to the neutrons, right? So again, when we think of our formula here, so the number of neutrons equals the mass number minus the atomic number. So if we know, you've already told me, that oxygen has a mass of 16. The atomic number is 8. So the 16 minus 8 will give me 8 neutrons. Okay, so oxygen has 8 neutrons in its nucleus. Okay, so a quick overview here of some important formulas, okay, and points that you do need to know. Okay, so don't be scared to star this as important information. The number of protons can be figured out by using the atomic number, and that atomic number also tells us the number of electrons, right? So protons equals the atomic number, and that also equals the number of electrons. Our mass number, okay, is going to be equal to our neutrons plus our protons. So we can reverse this and say that our number of neutrons, right? How do I calculate the number of neutrons? This is going to be the mass minus the atomic number, okay? And this by far is one that you will need to use the most often. So let's practice. Okay, so again, looking at your periodic table, find the element for sodium, right? So if we do look at sodium first, okay, so let's determine what the protons, neutrons, and electrons equal. Okay, so protons, based on our formulas, is the same as the atomic number. Okay, so when we look at sodium, sodium's atomic number is 11. The electrons, let's skip down to electrons. Electrons is also the same as the atomic number. So it too has 11 electrons. Now our neutrons is a little bit different. So remember, our neutrons is going to be our mass minus our number. So when we look at sodium, sodium has a mass of 23, and if we minus that atomic number of 11, it's going to tell us that there are 12 neutrons. Okay, so again, if you need to pause the video and give argon a try and try figuring out those protons, electrons, and neutrons, and then we will go over it together. Okay, so argon, when we find argon on the periodic table, the number of protons is the same as the atomic number, which is 18. The electrons, again, same as the atomic number, which is 18. And the neutrons is going to be that mass minus number. So the mass was 40, the atomic number is 18, which means that it has 22 neutrons. So this is a good example, as is sodium, that they're not all, the neutrons is not always the same as the protons and electrons. Sometimes it is, but sometimes it's not. So you do need to do the math every time to figure out the number of neutrons. Okay, so there's one more thing we want to talk about here, and that is standard atomic notation. So sometimes we don't always have that periodic table in front of us, and so another way of sharing this information would be using this standard atomic notation, which looks like, this. Okay, so it's another way to give us the symbol. Okay, the top number is the mass number, and the bottom number is the atomic number. Okay, so again, if you have this symbol, I guess you could say, from here you can still figure out the number of protons, the number of electrons, and the number of neutrons using this information. So let's practice writing it on the next slide here. So again, going back to sodium, so if we look at sodium again first, okay, so we first want to use the symbol, which is Na, when we find sodium on the periodic table there. And we said that the top number is the mass, so I'm going to round that top number to 23. And then the bottom number here is the atomic number, which for sodium is 11. So when I need to write out standard atomic notation, that is all I need to write out for that. Okay, so again, if we look at argon, okay, the symbol for argon is Ar, the mass is 40, and the number is 18. So that is going to be our standard atomic notation. Okay, so again, you have a practice sheet that you can practice finding the number of protons, the number of neutrons, the number of electrons using your periodic table, using that mass number and that atomic number to help you figure all of those out. Thank you.